Okay, in this diagram you are given a parallelogram, and the length of BM to MC, as you know, is 1 to 2, and the area of triangle BGM is 1 cm square. Okay, so now you need to find the area of the parallelogram ABCD. In fact, you no need to find all these sub-4 areas. Once you are given one parallelogram like this, and now you cut it diagonally. If you are given this area, one of this area, then you just times 2, then you can find the entire area of this parallelogram. Okay, so no need to find all these 4 areas. Okay, so what you should do now, you have to use some relationship between similar triangles. For example, like this. Okay, if you are given 2 triangles, they are similar to each other. If their area, okay, A1 to A2, and their length is L1 to L2, A1, A2, and then what are the relationship between A1, A2, and L1 to L2? You know that A1 to A2 will equals to L1 square to L2 square. Okay, in this parallelogram, can you find any similar triangles? Okay, give you some hints. BGM is similar to which triangle? Maybe you have some idea already. So it should be similar to this triangle AGD. So because they are alternate angles, okay, the same, okay, so that's why they are AAA. Okay, so you know that BM is 1. So can you tell me, how about the AD? If you look at the diagram carefully, can you see the BC? BC, you can see 1 to 2 divided by the M, and then what is the entire length of the AD with the entire length of the BC? Any relationship? As you know that it should be 1 plus 2, okay? That means equals 3, okay? The ratio BM to AD should be 1 to 3. So the area, okay, of the blue one, okay, so you should know that it should be 3 square. That means 9 cm square. Okay, so once you find this one, okay, how about the other area, for example, ABG, okay, ABG. Now this time you have to use another technique. The other technique is like this. Okay, on the straight line like this, if you draw 2 triangles on it, okay, with the same top vertex here, okay, if you are given the ratio, okay, R to S is their base ratio, and then what are the relationship of this bigger triangle and the smaller triangle? They are not similar, of course they are not similar, but they share something the same. Can you observe? If you can observe, they share the same height, for example H. Okay, the area of the left triangle, okay, what is the area? Okay, the area, okay, equals to R times H over 2. And then how about the triangle on the right side? As you can see that this triangle equals to S, okay, base times height. Height equals to H as well, and then over 2. So you know that the area ratio also to, okay, you can see the ratio very easily. It's also R to S, okay, because H over 2 will be cancelled to each other once you divided these 2 areas, okay, R to S. So now you already know that these 2 triangles should have some relationship, okay, these 2 blue triangle, or the top blue triangle with the green triangle. Okay, for example, the 2 blue triangles, okay, do you know the ratio BG to GD? Because they can be their same direction base, okay, this BG to GD, okay. So because you can see originally top and down there are 2 similar triangles, they are in the area ratio 1 to 9, so all the size ratios should be the same ratio as the other lengths, so it should be 1 to 3 as well, so it should be 1 to 3. Okay, so if the base ratio is 1 to 3, so the bigger one is 9, Okay, then you divide it by 3, then you can find the smaller one on the top, so it should be 3 cm squared. So once you know this part, okay, half of the parallelogram is 12 cm squared, okay, by addition of 3 and 9, then you just times 2, then you can get the answer D.